collect 1 and 3 yet. Okay? My last class had about 23 minutes of work time today to ensure that they had been doing questions 1 and 3 right, and to also work on 2, 4, and 5, which are the extra questions that I'm adding to your assignment that I'll be collecting tomorrow. So summarize that 1 through 5 due tomorrow, and you should have already done or at least started 1 and 3 based on our conversations from yesterday. And in a minute, as soon as I'm done, I will walk around and field all the was I right? How am I doing on this? Did I get the right answer? And I can look and get you some feedback on the ones you've attempted if you were able to attempt any last night. And luckily, if you haven't been able to attempt any, you're not getting penalized for that yet. So you will get penalized for that tomorrow if you still don't have anything for me by tomorrow. That was my first announcement. Second announcement is that I will be giving you detailed progress reports at the end of the period so that you can see exactly what your average is currently in PreCalculus. We'll talk more about that at the end of class. So right now, let's take a second, get to page 23, and we'll recap what we were hearing yesterday. After this question 1 only. Okay. So we are going to attempt a question to start class today with a function that's a fraction. We didn't see any like that yesterday. Yesterday the ones we were looking at were quadratics. We used box methods to multiply stuff out. We distributed, things like that. Today I need to expose you to the second type of function that you're responsible for, which are these fractions. On page 23, the instructions here on this example ask us to find the slope of the tangent line at any point. On your homework, those first 3, you're given specific points. So on your homework, you have the choice. Do I want to use method 1 or do I want to use method 2? On this question, because I don't give you a point, like a -1, whatever, I say at any point. This phrase here at the end means that I am being specifically told I have to use method 1 right now. And we'll recap what method 1 was, but that phrase at any point means you don't have a choice, unfortunately. You have to use the formula with the h's in it. Okay, so if I know that I'm going to need to be using method 1, the first thing I need to try to recall from yesterday's class is what was method 1? What was that formula? You have it in your packet. It's also on the poster directly above Emma's head back there that says definition of the derivative. The green formula is method 1. The orange formula is method 2 from yesterday's class. So right now we want to use the green one. First thing I'm going to do then is come over here, and you remember from yesterday we were writing m tan for slope of the tangent line equals that limit definition for method 1. F of x plus h minus f of x all over h. And I will always, as a very proactive move, record the formula that I'm using first. Once I get that down, I ask myself questions like, how can I make this very general formula specific to the situation that I'm in right now with a function of 4 over x? Usually the first thing that I will do is come over here, and instead of minus f of x, I actually write in what the function is so that I can ground myself in this specific equation of 4 over x. Notice I skip that first part immediately because that's something that I like to invest more energy in processing. But the function, I don't need to think at all about that. The function they gave me. I also don't need to think about the h down low. I just write that. And then it's definitely this blank space right here that I need to worry about. We talked about this yesterday. I'll show you the thing that everybody does wrong on this. They see f of x plus h and think that means their function plus an h after. We talked about how that's one of the biggest mistakes students make, just adding an h to the equation. That is not in any way, shape, or form what f of x plus h has ever meant. If my function is 4 over x, in slow-mo, what would 4 over 3, oh man, did you hear that? What would f of 3 be? 4 over 3. 4 over 3. I feel like I just said that. Sorry. How did I get 4 over 3? What did I do? Plug in a 3 where? For the x. So took the x out, put in a 3. What would f of m be? 4 over m. So what I'm asking is for f of x plus h. What do we think that would be then?
4 over x plus h.
4 over x plus h goes in the bottom. So that, I think about it, I write stuff down if I have to, or I just come right here and record 4 over x plus h. And ensuring that you have set this up correctly is like a very, very important first move. Because if you do something wrong in this line, you're going to run into some trouble navigating the rest of this problem. I promise, this is not something I want to emphasize too much, but I promise if I tried direct substitution right now, I would 100% all the time get 0 over 0. I am not interested in your ability to evaluate this right now at 0. I'm interested in all the algebra that has to happen and the final answer that we get at the very end. But 0 over 0 is always going to happen with the way that this definition is set up, and it's your job to do the algebra necessary to fix that oh no situation. Yesterday the algebra necessary was like a box. We did a box, it was fine. No need for a box here. And a lot of us, unfortunately, hate fractions, which is really sad in this example because we're going to be doing a whole bunch of fractional analysis right now. Let me compare this to something else. As often as I can, I'm going to try to show you what this would look like if it were just numbers, because I think you do better with numbers than you do with x's and h's and all that jazz. So let's say I had two fractions, maybe like 1/3 and 1/4, and I asked you to subtract those fractions. Because that's kind of like the situation I have over there in the numerator. I'm asking you to subtract two different fractions. How do I subtract these numbers? Yeah. Thank you. What would the common denominator be, by the way? 12. You just know that intuitively. There was a time when you didn't know that, and you had to think through very critically how to find a common denominator. You just said 12 right away because I think you multiplied 3 and 4 together in your head. If the common denominator is in fact 12, what fancy one do I need right here? 4 over 4. And what fancy one do I need over here? 3 over 3. That's how I'm generating the 12s down low. So I have to try and do the same thing in my scenario up top of my derivative formula, my slope of the tangent line formula. So I need a fancy one over here and a fancy one over here. Yep.
Do you need to multiply the first one times anything? Because when you just multiply the second one times h.
Okay, so if I did just an h over h, watch right now. Unfortunately, I get where that mindset's coming from, but that would generate a denominator of xh instead of x plus h. Great thought, though, which is why I need to be careful here when I set these up. This x plus h is behaving a lot like the 3 was over here, and the x is behaving a lot like the 4. So the first fraction needed the 4/4, which means my first fraction is going to need the x over x. Second fraction is going to need, any ideas? X plus h is, very nice. And here I am mimicking the scenario that we ran through over here with nice numbers. Okay, so again, if I had just regular old numbers, I think we would all agree, like both denominators here that I created for myself are 12s. And what would I get on my numerator of the first fraction? 4. Numerator of the second fraction? 3. You know what the answer is. We'll get there in a second. What I want to try and do is replicate this process where I simplified those fractions and I multiplied by the fancy ones. So over here, how about the limit as h approaches 0 of, I'm going to do some multiplying. X times 4, that's not difficult, that's just 4x. I'm feeling a little tired and lazy today, I'm just going to leave the bottom as x times x plus h. That would be like if I left the bottom over here as 3 times 4. But 3 times 4 is not hard to say 12. Here, whatever, right? We'll think about that later. Minus, second fraction, I hope we can agree, also has an x times h. Let me try this. An x times x plus h down below. And up top, again, I'm feeling a little tired. It's just something maybe like 4 times x plus h. Is that okay?
Yeah.
Over h. One of the other big mistakes students will make is they're getting so worked up with the fractions on top that they lose that h down low. So be careful that you bring that with you. Have it ready to go. Okay. What's the answer to this simple problem over here? 1 over 12. And you know that again intuitively because you're more comfortable with fractions now in this form. Once upon a time, though, I don't think everyone in here could just make that jump to 1/12, and your teachers back in middle school probably made you write a big fraction with a 12 on the bottom and a 4 minus 3 on top, right? Those two fractions became 1. And then you could get to the 1/12. But this is an important step for us right here with our complex fractions that we've got going on. So let me come up where I have some more room. What I see is two fractions that have a matching denominator of x times x plus h. So those can be smushed into one fraction. And now the numerators can just be written on top of that fraction bar. 4x minus 4 times x plus h. Maybe?
Oh, okay.
Good, thank you for helping me. When I look at the very top two right now, especially after seeing what happened yesterday, so much stuff was canceling for me, I'm really like wanting that 4x to be a, hold on, bless you. Second time this one sneeze won't come out. I blame you for blessing me too soon, but I will take the blessing, thank you. Okay, so let me try again. 4x, I wish that were minus 4x so that I could like get rid of them. What algebraic manipulation can I do then? Distribute. Let's clean this up so that yes, those 4x's can disappear. That would be best case. So I've got a limit as h approaches 0 of 4x minus 4x. As my second period was working a few minutes ago, one of the most common mistakes I saw was them on this next term putting a plus 4h in this situation. Keep in mind the 4 is negative, so I've got to bring the negative with me when I distribute the second to the second h. This is negative 4h right there. Over x times x plus h over h. Life is good, okay? We're getting close. Did I create something now where the 4x's can disappear? Of course. 4x minus 4x, that's out of here. And let me try to summarize the situation that we're in now. If I'm looking at this, I'm seeing a pretty meaty fraction up top. Like there's some stuff on that fraction up top, divided by a pretty simple value, h down low. So again, let me try to replicate that with real numbers and see if you could help me figure out how we can process this. I'm going to try and come up with a meaty fraction and divide by something pretty straightforward. How about 57 over 181, meaty, right, divided by like 2. That's me trying to replicate this scenario with real numbers. So just a side conversation right now. How did you learn to simplify something like this back in middle school? KCF, sure. Keep it, change it, and flip it. 1 over 2. Very, very nice. That 2's over 1, I flip, I do my math. Okay, so I want to try and do the KCF idea with what I have right here. So be careful. I'm going to keep the meaty fraction. Meaty, that's such a fun word. I'm going to keep the meaty fraction up top. Negative 4h times x times over x times x plus h. Changing that division to multiplication, and I need to flip the simple term in the bottom. The 2 became a 1/2. The h is going to become then 1 over h. Now that's a very, very, very crucial step. Believe it or not, I'm almost done. Multiplication, right? Yeah. If multiplication is the operation, I'm allowed to cancel stuff. Okay. H over H. H's are gone. And that is why the keeping, changing, flipping is such a crucial step here. H's are out of here. And if you're curious, as soon as I cancel the h over h, and there goes the 0 over 0 situation I was in with the direct substitution. Since the 0 over 0 is gone, let me do some DS now, direct substitution. What's left in my numerator?
-4.
-4 and a 1 multiplied -4. And in my denominator, I've got the x times x plus h. H is approaching, though, 0. So I'm going to plug in the 0 where the h was, and I'm going to simplify. That's -4 over x times x, or -4 over x squared. Wow. Pretty cool. What's that?
I had that too.
Thank you. Okay, so this situation that we are in with fractions is one where you can see that the math is different than it was yesterday. I'm not necessarily meaning to use box methods or a ton of like algebraic distribution and stuff like that. The big key factor here were these fancy ones at the very beginning. So that's the piece with fraction problems that you're really going to have to try to keep straight. I want to go to the next page now. I'm going to bypass those questions at the bottom and do another one similar to yesterday to help you out with those cases. But let me make sure I recap for you. With method 1, with the option we just used, now I have a formula here that I could evaluate at any point I give you for you to find slopes, right? I could plug in any x value, get slopes. That's what you're going to have to do on number 2 of your homework. Take all that work and evaluate your answer at a couple of places. Let's go to 24 and try one more that's a little bit more similar to yesterday's process. Number 2. Did I say 4?
No, I was number 2.
You said 24.
I said 24, which made me think of 4. Okay, I want to actually try 2, but I'm going to adjust this because I'd like to model something for you that mirrors number 1 from your homework last night, because that one might have been more challenging for you since we didn't see one exactly like that in yesterday's lesson. So do me a favor and mark out the equation on number 2, and I'm going to give you something fresh for us to try here. The equation I want is very similar, but x squared plus 4x. And the point will do -2, comma, -4. Okay. So I don't remember if I said this yesterday or not, but in situations like this where you have a point, you could do method 1 or method 2. You had 2 options yesterday. Whenever I have the options, modeling something for you, I am always going to do method 1. That doesn't mean you can't do method 2 based on what you saw yesterday, but because I know what's like a more important skill in the grand scheme of things, I'm going to try to emphasize method 1 as much as I possibly can for you, which is why I'm going to do method 1 again right now. If I'm deciding method 1, remember the first thing that I do is write the limit with the h in it. F of x plus h minus f of x all over h. That's the very general case, and I want to try to make it specific now to the function that we have. So nice first move that you can attempt right there is to create just this huge fraction with an h on the bottom, a minus sign up top, and where f of x is, you should definitely go replace with what our function is on that given question. I'd love feedback because this is something that I'm seeing a lot of, and it's okay, but it's not perfect, and it needs to be perfect. I see a lot of students taking the f out and putting an x squared plus 4x in exactly like that. And then they're concerned because they're getting the wrong answer at the end. But there's definitely a notation piece here that's currently missing. Any ideas? Gabrielle? Parentheses. If your function has several terms, mine has 2, I have got to put that entire function in its own group so that the minus makes its way to every term later. Okay? And then of course I have to think about what goes up front. Again, I'm trying to showcase this mistake as often as I can so that you don't do it, but I did this in my previous 2 classes and they were still making this mistake too, so it's okay. But what they love to do is write the function and add an h to it. And then I'll go look at their paper and I'm like, oh, you missed the first chunk. Try again. What? What do you mean I missed the first chunk? And I'll go back and I'll say, what you did is you wrote your function plus h. That's not what I asked for in the formula. I'm moving this parenthesis right here, and that has a huge impact on what we set up inside of that fraction. So I tried to introduce some other ideas to help with that. Your equation right here is like a template. And you need to think of it as a template that you substitute into. Ideas?
Can I see the remainder?
Yeah.
With x plus h squared plus 4x plus h.
That is exactly what I need to see. Beautiful. What she did was take these x's out. She kind of used these as placeholders, right? And where they were, she dropped in what we needed to be plugged into that function. Excellent work. Good job. Okay, and now that we've got this set up, I think you can see, okay, common denominators are not going to be a priority for me here because I don't have fractions with different denominators showing up in my formula, but I've got a ton of other algebra that I could do. This, oh, I saw someone last class do it. Don't you dare drop that square in there on both terms. Don't you dare drop that square. Oh. That reminded me, funny story real quick. I was talking in calculus the other day about absolute value bars, and Karina will giggle because I was so embarrassed. And we were talking, I said, how can you drop the bars, is what I said. No. And they just died laughing. I had no idea that was a thing, dropping bars. But dropping a square, that was something you cannot do. How do I handle x plus h squared?
X plus 2xh.
You memorize the result of that box, or you just draw a box real quick. We did this box yesterday, so I'm not going to draw it again. I think you'll remember it once I write it. X plus h to the power 2 is x squared plus 2xh plus h squared. That's never changing, friends. And by the way, that box is going to show up a lot. So you might just want to suck it up and remember what the three terms are that are going to come out of it. Plus. Okay, so I can check off the x plus h squared. Abrielle, what algebra happens here? Distribution. 4x plus 4h, right? And algebra on the last piece in black, a little bit more has to happen. Distribution. Negative's got to go to both. Negative x squared minus 4x. By the way, this is your paper. Come get it. All over h. Okay, so I had a student in first period who was asking me, Miss, like, it's kind of annoying that I do all this work and I get my answers at the end and I don't know if I'm right or wrong until the very end. Is there something I can be doing to check, like kind of self-check my work to know if I'm on the right track in the middle of this intense process? And I said, absolutely. When you get to this stage where there are no more parentheses anywhere in your numerator, stuff should cancel. Okay? And a very specific amount of stuff should cancel. So let me tell you how you can eyeball this. When you go back to the very beginning and you subtracted your function, in this example, my function had two pieces in it, right? The squared and the 4x. If I've done this right, every piece of my function should disappear because I will have another piece that zeroes it out. That means if there had been 9 pieces to my function, I would have had 9 pairs that I could get rid of. Here I had 2 pieces. Do I have the opposite signs showing up on the x squared and the 4x's? Sure. So that's a nice clue to me that I'm on the right track. The other advice I gave him is that, okay, if everything cancels the way you know it should also know if you're doing well by looking at your remaining terms. Every single one of them should have an h in it. Whatever's left over has to have an h. Do mine all have h's? First one? Yep. Second one? Yep. Third one? Yep. Did you hear that? Factor me! Factor me! Factor me! If they all have h's in it, what can I factor out? The h. This process is starting to get repetitive, right? It's going to repeat itself over and over and over again. The limit as h approaches 0, then, when I take the h out, leaves me with, let's see, h times what is 2xh? 2x. H times what is H squared? H times what is 4H? 4. H's are gone. And I know you get tired of me saying this, but when the H's disappear, there goes the 0 over 0. So direct sub is now a viable option for me, whereas it wasn't before. I annotate an equals with a DS, and I take everywhere there was an H and sub in a 0. That means I have 2x plus 0 plus 4, or 2x plus 4. Now, I want to hold you to really high standards with how you formulate your final answers for me. What you just decided is that the slope of the tangent line at any point can be found with the formula 2x plus 4. I gave you a point though, right? I want the slope of the tangent line at -2, -4. That vertical line is the word at. There's a place for that on your calculator too that we'll use a lot next year. This means I need to take 2x plus 4, and where there's an x, replace the x with what my specific x value is, which is -2. I do some math, I think I get an answer of C. Right? And then I'm set. Alright, so what I need you guys doing right now, look at that. So much work time. So much. 24 minutes if I'm not mistaken. So listen. Eureka. I am not going to beg you to do work. Please take advantage of this time and use it wisely. If you use it wisely, you'll be able to walk out of here probably with no homework, but you have to use it wisely. Help each other, and I'm going to start my circulations by checking for people who have answers from last night that they want to know if they did correctly. That will be my first lap. And then after I've given them feedback, I can start pinpointing like specific issues if you're having trouble getting started. 1 through 5 are due tomorrow. Cool? All right, let's get started. Jason, you can go ahead and turn that off.